Hello to all the wonderful people watching. In today's video, we will look into a concept called storage classes. But before we start, I would like to let you guys know that I have now started an Instagram page for this channel. Feel free to follow VAMcode in Instagram. The link is in the description. Alright, so let's get on with the video. A variable in C has an additional property known as the storage class. So an example of using a storage class would look like this. You have the storage class, the data type, and then the variable name. So what is a storage class? Basically, it gives us info about the following properties of the variable. First, it tells us how long the variable will exist in the program, or in other words, it tells us when the variable will be created and when it will be destroyed. Next, it tells us about the scope of the variable, or where all in the program you can and cannot access the variable. It tells us in which physical part of the memory the variable is saved to. For example, it could be saved to the stack segment, or in the static memory, or even in the register in your machine. Finally, it also tells us about the initial value of the variable. This is the value the variable has when it is not initialized. There are four types of storage classes in C: automatic, register, extern, and static. In this video, we'll be discussing the automatic storage class. By default, if you don't mention any storage class specifier for a variable, then it becomes an automatic variable. The keyword auto is used to declare an automatic variable. So let's take a look at an example. The code snippet shown prints 5 and 6 to the screen. Even if I had written the same code without the auto keyword, it still would have given the same output. That's why I mentioned that by default, if you declare any variable without specifying the type of storage class, the compiler will consider it to be an automatic variable, and hence nobody really uses the auto keyword. Let's look at a few properties of automatic variables. First, the scope of an automatic variable is inside the function or code block in which it is declared. You can't use it anywhere else in the program other than in the code block where it was declared initially. An uninitialized automatic variable will contain random chunk values, also known as garbage values. Third, automatic variables are stored in the stack segment of the memory or the runtime stack. They only exist as long as the code block they are in exists. Once the execution of the respective code block is complete, then everything in the stack associated with the variable will be cleared. And this is also why they're called automatic variables, as the allocation and deallocation of memory for automatic variables is done automatically by the operating system. In the following code, we see the function foo being called inside the main function. Inside the definition of the foo function, we see two variables, a and b, being initialized to 1 and 2 respectively. Both the variables belong to the automatic storage class. We print the values and then increment the values of both a and b. So now a is equal to 2 and b is equal to 3. In the next call of the foo function, a and b will get reinitialized to 1 and 2, and everything that we did in the first function gets repeated. So in the output, we will see a equal to 1 and b equal to 2 4 times, as we call the foo function 4 times. So what's happening here is that every time the function is called, the variables a and b come into existence. They're initialized, printed, and then incremented, but every time the control returns to the main function, the variables a and b are destroyed and no longer exist. Hence, the ++a and ++b statements are of no use here. Let's take a look at another code snippet. Since the scope of the automatic variables are within the code block they're declared in, we can have automatic variables of the same name in different code blocks without causing errors. The a and b in the foo function are different from the a and b in the main function. The foo function will print a equal to 1 and b equal to 2. In the main function, a and b are first equal to 3 and 4 respectively. Then they're incremented to 4 and 5 and then printed. And afterwards, if I call the foo function again, I'm going to get a equal to 1 and b equal to 2 again. The following code arrangement is also possible. int x is equal to 5 exists in its own separate block and hence will not interfere with the earlier declaration and initialization of x equal to 10. That'll be all for today's video. I hope this video was of help to you guys. Please do like the video if you've enjoyed it, and please don't forget to subscribe to see more such content in the future. Till we meet again, take care and goodbye.